All right, so we're going to talk about physical and chemical changes today. Because when a reaction takes place, some things physically change, right? Some things about just how it looks are going to change, and some things are going to chemically change. All right, so what are physical and chemical changes? That's what we're going to be able to talk about today, and the indicators of each. And then if we get to it, we'll talk about reaction types. But most classes have been working on the lab and the mom that goes with it most of the class. So by the end of today, you're going to be able to tell me the difference in physical and chemical change and what that looks like. So what are physical properties? If I told you to describe this mat on the floor up here, what would you tell me?
Blue.
Blue, yes, that's a physical property. You have to know anything about what that's made of to tell me that it's blue. No. All right, so how it appears, what the texture of it is. You can feel the top of your desk, right? And by feeling the desk, you didn't have to change the fact that it's a desk in order to tell me that it's smooth. Melting point and boiling point. This is one I see you get confused a lot. All right? If I have ice and I melt it into water, did I start with H2O? Is ice H2O?
Yes.
Yes. Is water H2O?
Yes.
So is melting a physical or chemical change? Did I change my substance?
No.
No, so it's a physical change. Now let's think about boiling. I put the water on the stove and I heat it up and it starts to boil until our gas is let off, right? And so now I have water vapor instead of water. Is it still H2O? Yes. All right? So no matter what phase change something occurs, it is still the same substance, right? Think about dry ice, frozen carbon dioxide. All right? When dry ice sublimes, which means it turns from a solid straight to a gas, right? So the boiling point of dry ice is so low that at room temperature it's already turned to a gas. That's why dry ice turns straight to steam, because as soon as it hits the temperature of the room, it turns to steam. All right? So carbon dioxide, once it goes from a solid to a gas, still carbon dioxide, just changed forms. All right, odor, if something has a smell to it, and then solubility, how something dissolves. All right, so for instance, if I stir sugar in my water, is it going to dissolve? Yes, but if I put oil in my water, say I get some vegetable oil and pour it in, is it going to dissolve? No. All right, so solubility means its ability to dissolve in water. And then polarity talks about the polar charges of a molecule, which we'll talk about more in Unit 7. But if you see something referring to polarity, that's a physical property. Let's talk about why solubility is a physical property. Right? So let's say I have salt, which is NaCl. So let's make little green circles for salt. All right? And then I have water. And I drop the salt in and I stir it up, right? And so here's my water particles. When I do that, do you think they combine like this and now make a new molecule? Or do you think it's option B here, that they're all just mixed in together? What do y'all think? Option A or option B? Andrew, what do you think?
Option B.
Option B, yes. All right, so notice none of them combine together to form a new compound. It's still salt intertwined with water, right? And that deals with the polarity that we'll talk about later on. But this is to show you, you didn't create a new molecule. Can I take the salt out of the water?
You can take the water out of the salt.
Yes, essentially, can I separate them again?
Yes.
Yes, that's how we get sea salt. Like when you put sea salt on your food, they took the seawater and they evaporated it out, got all the impurities out, and you're left with salt. All right, if you were to go home today, take a pot of water on the stove and pour a ton of salt in and dissolve it all while it's hot, and then let the water boil off, it'll make a mess. Mom might not be very happy, but you're left with the salt that you put in when you started. All right, so those are physical properties. Changes to physical properties are a physical change. Pretty simple, right? So physical changes are changes to some of those properties we just talked about. Crushing a can. Did I change the fact that it's a can?
Kind of. It doesn't hold things in.
Right. It it doesn't have the same purpose anymore, but is it still an aluminum can?
Yes.
Yes. Melting an ice cube, is it still water?
Yes.
Yes. Mixing sand and water. Did I change either one of the substances? No. Breaking glass. Still glass, right? Let's see. Dissolving, we talked about shredding, chopping wood, mixing marble, sublimation. That's another phase change. All of these, to some extent, can be undone, right? Paper, take it to a paper mill, put it in the recycling bin, and they mush it back up, and they make paper out of it again. This can be undone. All right, breaking glass. We can put some super glue in there and put it back together. Mixing sand and water, we can dry it out. All physical changes can be undone. Let's take a look at chemical properties. Chemical properties have to do with the actual chemical makeup of a substance. Toxicity. So that's whether or not when you eat it, what's going to happen to you. Why is that chemical? Because it tells you how the ions in the molecule interact with the ions in your body. Right, Lowell?
Yes.
All right? So, as they interact with each other, it can create something bad within your body. That's why if you eat something toxic, you may not be here anymore. All right? Oxidation states. That's your +1, -1, how many electrons it gains and loses. Heat of combustion, chemical stability. So how stable is that compound? Remember we said we can force group 18 into a compound. But does it want to be there? No. So it's very, very unstable. Flammability, whether or not it's going to catch fire. Gases catch fire way more easily than metals, right? Coordination number, reactivity goes kind of along with chemical stability. Reactivity, is it going to come together? Stability, is it going to stay together? And then possible chemical bonds that we just talked about. So ionic, covalent, metallic, what can that element form? And then enthalpy of formation. So how much heat does that reaction produce? So today in the lab, you'll see a reaction producing heat. And so enthalpy of that formation will be actually measuring the amount of heat that's produced. So chemical changes are going to change which properties? Physical or chemical ones? What do you think? The chemical properties, yes. So transformation of one or more atoms or molecules into something different, into different molecules. So your key that you need to highlight, if you want to write it big to the side somewhere, a new substance is produced. All right? That is your important part to note. You no longer have the same substance. So let's look at reacting hydrogen gas with oxygen gas to yield. What does H and O come together to form? Water. So here is a chemical change. Hydrogen gas exists as a gas at room temperature. Oxygen, also a gas at room temperature. But when I put them together, the bonds between these elements create new properties. What is water at room temperature? Liquid, right? You know that a change has occurred. Do I still have gas? Do I have any gas? Do I have hydrogen gas when I create water? No. Do I have oxygen gas when I create water?
Yes.
Oxygen gas?
No.
No. All right? So something completely has changed. I can't undo it. In the lab, some of our reactions we can undo. But outside of lab means it cannot be undone outside of a lab. So iron rusting. You can stop something from rusting further, and you can sand down the part that has rusted, but can you undo the rust? You ever see like the old trucks driving down the road, right? And there's rust eating away at the fenders, and maybe it's got some holes in the fenders. Can we undo that other than like putting a new fender on? No. All right, so, and you see that color change there that shows you there's some rust occurring. Burning wood. Can I put my wood back together? When you burn things, when you burn wood, like at a campfire, do you know what it actually produces? Any ideas? CO2 and
Water.
Water. Yes, good job. It produces water. Well, why is your fire not wet? What happens to the water that's produced?
It's in the air.
It's in the air. Fire's hot, right? What happens to water when it gets hot? It boils and evaporates. So, if you're out roasting marshmallows, you're creating dirty air and water. The water evaporates with everything else. Metabolism, you're not getting that food back, all right? And even if you do, it's not the same form. Cooking an egg. right? You've changed the proteins. When you cook food, that's why they say like raw food sometimes are better for you than cooked ones, because you break down the proteins and you break down the makeup of those things. You can't get it back. So just look at all of these different examples and think, I can't get it back once it's done. Fire explodes on fireworks. I can't go pick up all the pieces and set it off again. All right? So, can physical changes, matter changes form, but not identity? I still have paper, I still have marbles, I still have wood, and I still have water. Right? But in a chemical change, that reaction creates a new product. Yes, this is still a banana peel, but it's now rotting. It's decomposing. It's not the same thing anymore. All right? So then comparing the two. So in a chemical change, you see a change in the chemical composition of the substance. Like it is no longer chemically the same at all. Ladies, when you dye your hair, that is a chemical change to your hair. You no longer have the same makeup in your hair. That's why like you can't donate hair that's been dyed. But then in a physical change, the only difference is in your appearance, shape, size. So think dyeing your hair versus cutting it. All right? So when we look at this table, these things right here are signs of a chemical change. So the things we look at, fizzing and foaming. Does anybody know what's produced when you get fizzing and foaming? Any ideas? What's it say on the board?
Release gas.
Release of a gas. Good job. So when things fizz and foam, they release a gas. That means that something reacted and let off either hydrogen gas, oxygen gas, some type of gas was released as a result of the reaction. Heat. This heat means the actual production of heat. Not that you applied heat to the substance, but that you poured two room temperature substances together, and when they poured together and reacted, it got hot. You felt the beaker, and now it's all of a sudden hot, and you didn't put it on anything to warm it up. All right, production of sound, light, and odor. So you end up with a new odor. It didn't smell. You poured two odorless chemicals together, and now all of a sudden it smells terrible. Right? We talked about combining bleach and ammonia. Right? It's an awful smell. It lets you know, hey, some kind of chemical reaction is taking place here. Like, you need to be aware. So another one is change in color. Change in color is another chemical sign of chemical change. Change in color. So notice a lot of these signs of chemical changes are what type of changes? Yes, good job, Deborah. Physical changes, right? If I change the color, color is a physical property. That was a physical change that indicated my chemical change. Because can I see the little molecules moving? No, right? Odor, again, is a physical property. But when I have a change in odor, it indicates, hey, you might have a chemical reaction occurring. All right? These changes cannot be undone. Once the gas is released into the air, I can't force it back into my substance. All right? So a lot of times, physical changes indicate that there was a chemical change that occurred. All right? Any questions on this?